The last topic that we're going to talk about in the L'Hopital is going to be about power IF. The power IF gives you in the way that you have y equal to fx to the gx. Let me recall you about the exponent a little bit. So you have a to the 0 equal to 1 when a not equal to 0. And normally you're going to say 0 over 0 is undefined. Okay, so this one is the thing that you may have been studying from high school before, that you have 0 over 0 turn out to be the thing that undefined. However, in this L'Hopital, we're going to talk about 0 over 0 as an indeterminate form. So we're going to include 0 to the 0, not 0 over 0, 0 to the 0 as an indeterminate form. Okay, together with other one, which are 1 to the infinity and infinity to the 0. I will explain why these two guys are indeterminate form. You may ask me whether this 0 to the infinity, 0 to infinity equal to what? And you have infinity to infinity should be equal to what? 0 to the first equal to what? And you have 1 to the 0. Okay, let's answer this four guy first. So you have 0 to the infinity. This guy is 0 times 0 times 0 times 0. So it's no need to think. So it's going to be just 0. And infinity to the infinity turn out to be just infinity. Pretty clear. And 0 to the first is going to be just 0. 1 to the 0 turn out to be 1. Okay, so they are not indeterminate form. They be able to determine for value. However, if you have 0 to the 0, 1 to the infinity, and infinity to the 0, we do have the indeterminate form. Let me explain why. So first, you're gonna write this one as y equal to fx to the gx. And when we study implicit differentiation, this guy can be written as e to the log of fx to the gx. So you see that this guy cancel each other. So you just get fx to the gx. And you're gonna pull out gx. So it's gonna be e to the gx log fx. Okay, so this is what we have now currently. So you have gx log fx. And then what? And then you're gonna think about gx times log fx. So you would have gx log fx. Okay. So this one, you see that it is a product. Okay, so when you have a product, you're gonna think that this guy must be indeterminate form in terms of 0 times infinity, because we have only one indeterminate form for the product one. It's gonna be 0 times infinity that we don't know about it yet. So when you have 0 times infinity, we have several cases. So in this case, you can have gx equal to 0, gx equal to 0, and you have log fx equal to infinity. Okay, so you have gx equal to 0 and log fx equal to infinity. So in this case, you would conclude that you have fx must be infinity. Okay, so you have fx must be infinity. So you're gonna get fx equal to infinity, and don't forget that you can have fx equal to 0 also. Okay, so when you have fx equal to infinity, it's gonna be log infinity, and log infinity equal to 0. Log infinity equal to infinity. And when you have fx equal to 0, so you have log of 0. So in the graph, you're gonna get the function equal to negative infinity. Okay, so that's the reason why we say that fx equal to infinity or 0. Okay, so in this case, let me make this one clearer. So this guy is gonna turn out to be 0 times plus minus infinity to be exact. Okay, so this one we have, and you have log this guy, and you're gonna have two cases. The first one gives you infinity, the second one turn out to be 0. The second one, okay, so the second one, so let me conclude also. So we get fx is infinity, so we get infinity to the 0, and we get 0 to the 0. Okay. The next case, for the second case, I would have so this one I could have gx to equal to positive, negative, infinity, and you have log fx equal to 0. Okay, so you have log fx equal to 0 in this case. So and log fx equal to 0. And so you solve for fx, you get fx equal to 1. And we get 1 to infinity. Okay, you don't need 1 to the positive, negative, infinity. It doesn't matter. It's going to be 1 to negative, 1 to infinity. That's fine. So you have three kinds of indeterminate form, namely infinity to 0, 0 to the 0, and 1 to the infinity. I usually tell my student that try to convert fx to the gx in terms of log first. So you're gonna convert from the pink one to the green one, and then you see whether you have 0 times infinity or not. If this green guy equal to 0 times infinity, you get indeterminate form. If the green guy does not equal to 0 times infinity, you gonna not get the indeterminate form. So you just maybe fall into these four cases. Okay, so we're gonna use L'Hopital only when you have, after taking log, it's gonna turn out to be gx log fx, and it's gonna turn out to be 0 times infinity. Otherwise, it's not L'Hopital. Okay, so in this case, you're gonna find the limit fx to the gx by converting to e to the green one. Okay, so you have e to the green one, and you will use L'Hopital. So the first step will be here. So this one will be your first step. And the second step will be you find the limit. Okay, so you find this limit by using L'Hopital. So let me circle this one with other color. So this one is your second step. So your second step is here. Okay, so you find this limit by using L'Hopital. So find this limit by L'Hopital. Okay, so that's fine. So this one is number 2. This one is number 2. So we're gonna, okay, so I'm gonna have to emphasize on this one that the limit of gx log fx here turned out to be the if 0 times infinity. if you not have this guy, you're not using L'Hopital. Okay, so it's going to be just this form, this form, this form, or this form. So you just be able to get the value quite easy. Let's see example. So for this example, you're gonna get limit x go to infinity of 1 plus a over x to dx. Okay, so it's gonna be fx to the gx. So in this case, let me highlight something. So it's gonna be this guy. Okay, so this one will be your x, that will be power, and you have 1 plus a over x, which is your fx down here. Okay, so you're gonna convert this limit to, okay, so this guy equal to e to the limit x go to a, and you have fx come down, so it's going to be not fx, x come down, and it's going to be log 1 plus a over x. So this guy, you have x come down, and you have 1 plus a over x, like this. And this guy turned out to be final answer in terms of e to some power. Okay, so it's going to turn out to be e to some power. And that power turned out to be the thing that we are looking for. Okay, so the first step will be you convert into limit of x log fx. So it's going to be you convert into e to the limit. Okay, so this one is not x go to a, sorry, it's going to be x go to infinity. And then the second step, you're gonna compute the limit. So the second step, you're gonna compute limit x go to infinity of x log 1 plus a over x. Okay, so this one by using L'Hopital, so it's gonna be infinity, and you have log 1 plus a over x and 1 over x like this. And you see that you must check whether you get IF. So in this case, when you have x go to infinity, so this guy will be infinity times log, and a over x turn out to be 0 in this case. So it's going to be time log 1. So infinity time log 1 is infinity times 0. Okay, so this one is indeterminate form. Okay, so this one is indeterminate form. And then when you have infinity times 0, you're gonna convert this thing to log 1 plus a over x over 1 over x. And when you have x go to infinity, this guy go to 0 and this guy go to 0. So you would get log 1 over 0. So you have 0 over 0 in this case. Okay, so you're gonna just apply L'Hopital 0 over 0. So you could get limit x go to infinity. Okay, and you dip log is gonna be 1 over 1 plus a over x, and dip a over x is negative a over x squared, and dip 1 over x turn out to be negative 1 over x squared. Okay, and then you get rid of negative side, so you get rid of this guy and this guy, so you would have a. Okay, so in this case you gonna just get, okay, negative here, so it's going to be you get rid of negative. So in this case you would have limit x go to infinity of a over 1 plus a over x, and you have x go to infinity, so it's going to become 0. So the limit turned out to be equal to a. So when you have limit equal to a, the third step will be you gonna plug in this A back into the first line here. So you have A here and you're gonna plug this A back up, okay, to this guy, and this one will be your final answer. So the final answer will be e to the a. The final answer is not equal to this, okay, not final answer. The final answer will be, you have to plug a back here, so the final answer become here, okay. So this one is the final answer, okay. So it's going to be e to the a for final answer, okay. So let me write down, this guy is the third step. So it's going to be the first step, the second step, and the third step, okay, for the power law Pitan. The next one is you have limit x go to 0 of x to the psi x. So in this case, you first convert this guy in terms of e to the psi x log x. Okay, so this one, let me highlight this one for you. So you have the pink guy, which is your psi x. You have the yellow guy, which is x. So it's gonna be x and you have psi x. Okay, so in this case, you be able to find this limit. So let me move this one a little bit. So you're gonna get this one and you move this one and you have limit x go to 0 from the right, okay? And you're gonna find this limit. So this one is your first step. And this guy turned out to be e, and we are looking for this final limit to final answer, okay? So we need to compute the limit, okay? So let me compute limit x go to 0 from the right of psi x multiplied with log x. Like I said, you have to first check whether you get indeterminate form. So you get psi 0 and you have log 0, and this guy equal to 0, log 0 equal to negative infinity. So you get IF, okay? So you get IF, okay? So you have 0 times infinity, IF. So in this case, you're gonna just, okay, so you now have 0 times negative infinity, and you're gonna change this guy to the quotient. So I'm gonna move psi to the bottom because we have many trigonometric identity for the reciprocal. However, if you have it for the log, it's gonna be kind of more complicated, okay? So you get this one, and you see that the bottom guy turned out to be cosec x, okay? 1 over psi is cosec x. And this guy, when you have x go to infinity, this when x go to 0, it's going to be 1 over 0, and it's going to be log 0. So it's going to be infinite over infinite. Okay, so it's turned out to be infinite over infinite. So in this case, you get, okay, so you get to differentiate. So you use L'Hopital. So you use L'Hopital, infinite over infinite. So you have limit x go to 0 from the right, and you differentiate. So you differentiate log, you get 1 over x. You differentiate cosec, it's going to be cosec x cot x. Okay, so it's going to turn out to be cosec x cot x. And we see that cosec x cot x turn out to be 1 over psi x, okay? And cot x turn out to be cos x over psi x, okay? And you see that this guy is limit x go to 0 from the right. And you can combine this guy and this guy, Okay, so you can combine this guy and this guy together. How? So you'll be able to flip up this term. So you're gonna flip this one up. So you would get psi x over x on top. Okay, so you would get psi x over x on top, and you'll be able to flip this guy up also. So you're gonna flip psi up on top. So it's gonna be, let me write this one in this way. So you have the green color, so you get psi x over x. So this one is the pink one, and psi over cos will be on top. So it's going to be like this for the yellow one. So you flip the yellow one up, so you flip the pink one up like this. Okay, so in this case, it's gonna turn out to be limit x go to 0 from the left of psi x over x, and you have psi x over cos x. And we learned that this limit gonna be equal to 1. Okay, this limit gonna be equal to 1, and another limit will be psi 0 over cos 0. Okay, psi 0 over cos 0 turn out to be equal to 0. Okay, so in this case, this limit turn out to be 1 times 0. Okay, so the pink guy turned out to be 1, the yellow guy turned out to be 0 in this case, and the limit turned out to be 0 total. So this one will be the blue one that you're looking for. Okay, so in this case, you're gonna answer e to the 0. Okay, so you get e to the 0, and e to the 0 equal to 1 for final answer. So your final answer is here. Okay, so this one is final answer. So this one is your third step. Okay, so you have to put back here. Okay, let me go up, 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 like this. Okay, and this one is your third step. Okay, so this is the all that we have for this limit. And you see that this one 0 to in, so this one is gonna be the limit that we have. Okay, the next one, you have limit x go to pi over 2 from the left of tan x to the cos x. So in this case, for this guy, it's gonna be, you change this one into e to the limit x go to pi over 2 from the left of cos x log tan x. Okay, so in this case, this one will be e to the limit that you're gonna find in the second step. So this one is your first step. Okay, for the second step, you're gonna find limit x go to pi over 2. So it's gonna be limit x go to pi over 2 from the left of cos x log tan x. Okay, so it's gonna be cos x log tan x. And this guy, you see that you plug in, so it's gonna be cos pi over 2. So it's gonna be cos pi over 2 times log tan pi over 2. So this guy will be log infinity. This guy turned out to be 0. Okay, so it's gonna turn out to be 0 times infinity. Okay, so we have an indeterminate form. After we check this one, we're gonna move cosine to the bottom in order to obtain infinity. over infinity. So it's going to be pi over 2 from the left, log 10x, okay? And you have 1 over cos x like this. So you would get infinity over infinity, okay? And then you're gonna change this one in terms of the function that you can differentiate easier. So in this case, you're gonna have, so you're gonna have limit x go to pi over 2 from the left of log 10x over sec x. Okay, so it's going to be over sec x. And you dip log 10, so it's going to be limit x go to pi over 2 from the left. Dip log 10x is going to be 1 over 10x. Okay, and dip 10, you get secant square. So the bottom guy, you dip sec, you get sec x 10x. Okay, so this one is L'Hopital, infinite over infinite. And this one is the orange one. Okay, I'm gonna just highlight on the bottom, only the top, we don't need to highlight. And you see that secant and secant square cancel each other. So you get one secant left and you have 10, 10 on the bottom. Okay, so you would get limit x go to pi over 2 from the left, and you have sec x over 10x square. Okay, and for this one, you're gonna have 1 over cos x. Okay, and you have 10x squared, so it's gonna be sine x over cos x, sine x over cos x, like this. And you see that cos will be get rid of each other, one term, and you have cos over sine square for the final term. So you would have limit x go to pi over 2 from the left, and you have cos x over sine x square, sine x square. And then what? And then you're gonna take the limit. So it's gonna be cos 0 over sine 0, not 0, pi over 2. Yeah. Cos pi over 2 sine pi over 2 square. So it's going to become 0 over 1 square equal to 0. Okay, so in this case, this is what you get. And you have the final answer equal to 0, e to the 0. So it's going to be what? It's going to be 1 for final answer. Okay, so this one, you move this one up. Okay, and this one turned out to be 1. And this is your third step. Okay, so power L'Hopital is consists of 3 steps all the time. I'm never say that it's going to be 2 steps. It's going to be 3 steps. Don't forget the final step for plugging the limit that you have back into the original e to that power. I believe this one is not the last one. We're going to have another 2 for the limit. The next one, okay, I'm going to do this one faster. So for this one, it's going to be e to the root x, right? So this one is e to the root x. So you have e to the limit x go to infinity of root x log of 2x over 2x plus 3. Okay, and this one turned out to be e to the what power. Okay, and you're gonna have limit x go to infinity of root x. Okay, so you need to find this limit. So this one is your first step, and your second step is here. So your second step is here. So it's going to be root x and log 2x over 2x plus 3. Okay, so this guy will be limit x go to infinity, and you have log of 2x over 2x plus 3. Okay, and everything is going to be 1 over root x. Okay, and you see that when x go to infinity, this guy, okay, gonna tend to log 1, okay, equal to 0, and this guy gonna tend to 0. So in this case, you're gonna apply L'Hopital, the version 0 over 0. So this one, you're gonna use L'Hopital 0 over 0, okay? So in this case, before we differentiate, we should simplify this one a little bit, because we're not going to differentiate log of the quotient. It's going to turn out to be more difficult. So you're going to expand the top one. Okay, so you'll be able to expand this one into log of 2x minus log of 2x plus 3, and this one over 1 over root x. Okay, and then what? And then this guy will be limit x go to infinity, and you dip 2x, so it's going to be 1 over 2x times 2, and it's going to be 1 over 2x plus 3 times 2 also. Okay, and you have the bottom. This guy is x to the negative 1/2, so it's going to be negative 1/2 x to the negative 3/2. Okay, so this one is going to be cal. And the next one you need to simplify. Okay, so we need to simplify this one. So we done with cal here. Now we're going to use algebra in order to deal with this fraction. So we can begin by canceling these two first. Okay, so we begin by canceling these two, and I'm gonna kind of move this term. Okay, so I'm gonna move this term to the top. Let me circle this one nicer. So you move this term to the top. So everything turned out to be what? Let's see what's going on. So this guy is gonna be limit x go to infinity. Okay, so for this one, it's gonna be what? It's gonna be 1 over x, 1 over x minus 2 over 2x plus 3. Okay, okay, so this guy, let me write it here, 1 over x minus 2 over 2x plus 3. So in this case, you can combine this guy into 2x plus 3 minus 2x, and it's going to be over x times 2x plus 3. Okay, and you have the red guy come up, so it's going to be negative 2x to the 3 over 2. Okay, and what you will have will be 2x and negative 2x cancel, so it's going to be negative 6x to the 3/2 over the bottom guy turned out to be 2x squared plus 3x. Okay, so you get 2x squared plus 3x. Okay, with me so far. And then you have limit x go to infinity, and you have negative 6x to the 3/2. And don't forget that when we are dealing with x go to go to infinity like this one, we're not factoring. We're gonna try to pull out the highest power. So in this case, you're going to pull out x squared and you get 2 plus 3 over x left on the bottom. Okay, so this is the trick that we have learned. And this guy is going to be negative 6 over root x. Okay, so this one and this one cancel each other. And you have 1 over 2 plus 3 over x. And you have x go to infinity. So this one is 0, this one is 0. Okay, so basically this guy equal to 0. Okay, so you have 0. So you get 0 times what? Times 1/2. Okay, so basically give you 0. So this will be the blue limit that we have. Okay, so this one that I highlighted blue before. And then we're gonna plug back in. Okay, so we're gonna plug this guy back into the original limit. So this guy go here. Okay, so this guy go here. So it's gonna go this guy. So it's gonna be e to the 0, and e to the 0 equal to 1. Okay, so you get e to the 0 equal to 1. So this one is number 3. The last one, okay, it's not last one yet, so we still have 2 more. You have limit x go to 0 from the right of sine x to the 1 over 2 log x. Okay, so this one will be e. Okay, so this one will be e to the limit x go to 0 from the right, and this guy will be 1 over 2 log x and log sine x. Okay, so it's gonna turn out to be this limit, and this one is gonna be e something, I don't know it yet. So this guy, when we have this one, is going to be number 1 and number 2. Okay, so it's going to be limit x go to 0 from the right. Okay, and you need to find the limit 1 over, it's going to be log sine x over log x. Okay, so this guy will be the thing. And you see that this guy become log 0 over log 0. Okay, and log 0 equal to negative infinity. So you will use L'Hopital infinite over infinite. Okay, so you will use L'Hopital infinite over infinite. So in this case, it's gonna be limit x go to 0 from the right, and you differentiate log sine is gonna be 1 over sine x, and dip sine is cos. So that one term, and you dip log x is going to be 1 over x. Okay, so in this case, you see that it's look kind of the thing that we had before. So you have limit x go to 0 from the right, and you see that the top guy turned out to be cosine x. Okay, so that guy will be on top. On the bottom guy, it's going to be sine x over x. Okay, so this one is your algebra. And then you see that you not have to dip anymore because you have the limit of the bottom. Limit of sine x over x turn out to be equal to 1. Okay, so this guy go to 1. So it's going to be cos 0 over 1. Okay, and it's gonna turn out to be equal to 1. Okay, so in this case, it's gonna be, I forgot 2, sorry. I forgot 2 times 2 times 2. Okay, I forgot 2. And then I have 2, so the limit turned out to be 1/2. Okay, so the limit turned out to be 1/2. So in this case, this guy is going to be 1/2, and you're gonna just have square root e for final answer. Okay, so it's turned out to be square root e for final answer. That's all. Okay, so this one is not that hard. It seems difficult. However, the thing that normally students hate to do is gonna be sine x over x. Okay, so when you see something like this, try to combine, try to make sine x over x in order to ease your calculation. If you continue differentiating, you go nowhere, basically. Last one. Last one, you like to have limit x go to 0 from the right of 1 plus sine 4x to the cot x. Okay, and the thing that you see here is seem difficult. However, this one turned out to be pretty easy at the end. So you see that this guy can be written as e to the limit x go to 0 from the right, and you have cot x log 1 plus sine 4x. Okay, so you have cot x log 1 plus sine 4x. And this one is e to what power? This is what you have. And then you're gonna compute limit x go to 0 from the right of log 1 plus, it's gonna be cot x log 1 plus sine 4x. Okay, and this guy turned out to be limit x go to 0 from the right, and you see that this one is gonna be what? It's gonna be sine 0, so cot 0 is infinite, log 1. Okay, sine log 1 plus sine 0, so it's gonna be log 1. So this guy will be infinite times 0. Okay, so this one is an indeterminate form for sure. Let me change the color a little bit. I like to change the color for this one. Okay, so in this case, this one, we're gonna convert this one into log 1 plus sine 4x. Like I said, it seems difficult. And you have 1 over cot x. Okay, and what is 1 over cot x? 1 over cot x is tan x. Okay, so the bottom guy turned out to be just tan x, not that hard. Okay, so the bottom guy turned out to be just 1 over cot x, so it's gonna be just tan x. And this guy, you have log 1 equal to 0, and this guy you get tan 0 equal to 0. So you're gonna use L'Hopital 0 over 0. Okay, so this one is gonna be L'Hopital 0 over 0. And you differentiate. So you get limit x go to 0 from the right, okay? And you get 1 over 1 plus sine 4x, okay? 1 over 1 plus sine 4x. And you dip sine 4x, you get cos 4x times 4, okay? And you dip tan x, you get sec square x, okay? Like I said, this one seemed difficult at first, but after using L'Hopital, you see that turned out to be pretty clear that it's gonna turn out to be cos 0, okay, times 4 over 1 plus sine 0. And this guy turned out to be sec square 0. So in this case, you get 4 for your final answer. Okay, so the limit turned out to be equal to 4, and you're gonna have 4 here. Okay, so you're gonna have 4 here, and this will be your final answer. Okay, so it's going to be e to the fourth for your final answer here. Okay, so let me conclude that we have three kinds of L'Hopital. Okay, so we have three kinds of L'Hopital, not three kinds of L'Hopital. So it's going to be three kinds of indeterminate form. You're going to have 0 over 0, infinite over infinite, the basic one. Okay, and we have the second kind, which is 0 times infinite and infinite minus infinite. Okay, so this one I told you, you change to 0 over 0, infinite over infinite. Okay, and the last one will be the power IF. I'm not gonna ask you to memorize power IF because not memorize. So this guy you think about, so you take log, okay, and you would get 0 times infinity. Okay, so power IF, after you take log, you're gonna get 0 times infinity, and you're gonna convert this guy to, okay, and this one turned out to be the second type. So this guy convert to 0 times infinity. This guy convert to 0 over 0 and infinity times infinity. So every indeterminate form, you'll be able to convert into the basic ones. Okay, so the basic one is 0 over 0 and infinity over infinity. Okay, so I think that should be all for this lecture on L'Hopital. Okay, we have many tricks and we have many algebra. Like you can see here, you differentiate for the L'Hopital, and from this line, you're gonna use algebra. Okay, so you're gonna use algebra in order to simplify the term. Okay, so it's not L'Hopital PL, it's going to be, you need to use algebra also. And the trigonometric identity, you use it a lot. Okay, and don't forget sine x over x, when x go to 0, it's going to be 1. Okay, okay, so that's it for this video. Okay, and that is going to be your chapter 4 exercises on this topic, 4.4, 7 to 65, to see that you have many examples, and you have exercise chapter 4 review on number 7 to 14 as well. Okay, so that's all.